15. We have an integral from 2 to infinity of x e to the negative x squared dx. Right. So to recognize that that's an improper integral because it has the infinity, right? So if we rewrite it as the limit as b approaches infinity of 2 to b x e to the negative x squared dx. And then recognize also that if we were to substitute this negative 2x, or this x squared, the derivative of that would be negative 2x, which would be related to the x and the dx. So it would be a pretty typical u substitution problem. So then d would be negative 2x dx. And if we replaced here, we'd have e to the u. And then the x dx here that we have to replace also can be replaced by, get rid of that 2, put it over here, it'd be a half du. Whoops, you're right, negative. So negative 1/2 du would be our x dx. So take a negative 1/2 out here, du here. Right. And so that would be the substitution part. And then from there we could anti-differentiate. We get negative 1/2 e to the u, negative 1/2 e to the negative x squared. 2 and b. Alright, and if we put our b in there, we get negative 1/2 times e to the negative b squared minus, and we'd have e to the negative 4. Put a 2 in there. And then remember the final step here is to figure out if that actually has an answer. And remember it doesn't have to. We could get diverged here possibly. It could be infinity. All right, but ultimately let's see what happens. We're going to get negative 1/2 here. And what's going to happen if we put infinity in here? If we square infinity, we're going to get infinity. But it's going to be e to the negative infinity, which ultimately e to the negative infinity is going to be what? 0. And then over here, it doesn't depend on b, so it's just going to be minus 1 over e to the 4th, if you will. And so with that, we're going to get positive 2 e to the 4th, which hopefully corresponds to one of our choices. Actually, they didn't put the e to the 4th on the bottom. I guess they just left it on top, so it should be letter C. All right. Any questions on any steps on the improper integral one? What else? 1 through 28. Jake?
7.
On 7 we have the limit as h approaches 0 of tangent pi over 4 plus h minus tangent pi over 4 all over h. And bottom line here is we need to recognize that this is just a derivative. We're putting an x plus h and an x in. So ultimately this is really just the derivative of tangent. Function is tangent x at x equals pi over 4. And what do we know about the derivative of the tangent? Secant squared x. And so if we do secant squared x at pi over 4, secant of pi over 4, the tangent of pi over 4 is 1. Sine and cosine are equal to each other. And since the, actually I lied, I don't care about tangent, I want to know cosine, sorry. So cosine of pi over 4 is radical 2 over 2. And so the secant of it would be the flip of that. So it would be 2 over radical 2 all squared. So again, secant of pi over 4 is going to be same as 1 over cosine of pi over 4. So flip cosine of pi over 4 and then square it. We get 4 over 2. So we'd ultimately get 2. The letter E. What else? 1 through 28. calculator part. 29 through 45. Plus? 41. Alrighty. On 41, we have a rectangle inscribed in the curve e to the negative x squared. It's your function today, isn't it? Alright, and we ultimately want the maximum possible area of this rectangle. Alright, so if we're going to maximize the area of that rectangle, we need to write an expression for the area of it first. So we know it's length times width. The length here in this picture would be 2x. And e to the negative x squared would be the other dimension. True? And so with that, we need to maximize that. We'd want to find what? What's that? Yeah, find the derivative. We don't know how far this thing is to the right and left, right? So it's x to the right, x to the left. It'd just be 2x for the one dimension. And if we found the derivative here, our derivative is going to be the product rule here. So we're going to go first times the derivative of the second is going to be itself times negative 2x plus e to the negative x squared times 2. Right, and so we ultimately get negative 4x squared plus 2 times e to the negative x squared. Just going to factor out the e to the negative x squared since they both have that in common. We have negative 4x squared in the first piece and 2 in the next one. Alright, and we ultimately want to know, when does this equal 0? Well, when does this function equal 0? You've got a picture right in front of you. Does it ever equal 0? No. So when does this equal 0? So if I were to do 4x squared equals 2, I'd get x squared equals a half. 2 divided by 4. So it'd be x equals plus and minus 1 over radical 2. Alright. And just for argument's sake here, keeping in mind that this is a calculator problem, if we were to just put that in the calculator instead, we could get our answers that way as well. Get our 0 command. Gives us negative 0.707106778. Which is ultimately the same as 1 over radical 2. So we can get them either way. Alright, bottom line here is though is that if that's our x dimension that maximizes here, the question though says find the maximum possible area. So is this the area? No. Okay. You'll notice that it's a choice though, isn't it? Part C, choice. So where's this 1 over radical 2 going to have to go? It's going to have to go into the area function, which we wrote up here. So if I go 2 times our answer, I don't necessarily need to do all that, but alright, and then E to the negative, and then our answer squared. .86, which should be letter D. Assume that's good. Yep. Okay, questions on number 41. Okay.